Combining two different circuits from two different directions within the same junction box in a residential setting, such as circuit 16 and 14, is permissible under the National Electrical Code, or NEC, provided specific safety measures are strictly adhered to. It's a common and accepted practice when done correctly. There are 4 primary safety considerations to review. Firstly, proper circuit identification is paramount. Each circuit must be distinctly labeled with its corresponding circuit number and voltage at every accessible location. This clear labeling serves a vital purpose. It minimizes the risk of accidental contact with live conductors and ensures that the appropriate circuit is de-energized during troubleshooting or maintenance activities. Without proper labeling, confusion can arise, potentially leading to dangerous situations. Secondly, a common overcurrent protective device is required. Both circuits must be connected to a single circuit breaker or fuse designed to trip when either circuit experiences an overcurrent condition. This shared protection mechanism is critical for preventing conductors from overheating, which can initiate electrical fires. The overcurrent device acts as a safeguard, interrupting the flow of electricity when a fault or overload occurs on either circuit. Thirdly, conductors must be appropriately sized. The conductors used for each circuit must be adequately sized to handle the anticipated amperage draw of that circuit without exceeding their ampacity rating. Undersized conductors can overheat, leading to insulation damage, potential fire hazards, and voltage drop, which can impair the performance of connected devices. Consulting the NEC tables is essential for selecting the correct conductor size based on the circuit's amperage and other factors. Finally, sufficient box fill is essential. The junction box itself must be of adequate size to accommodate all conductors, splices, wiring devices, and any other components housed within it. Overcrowding a junction box can lead to several problems, including difficulty making proper connections, damage to conductor insulation, and increased heat buildup. The NEC specifies box fill calculations to ensure that boxes are not overloaded, providing ample space for safe and reliable electrical connections. Now we will go into these safety considerations in further detail. Let's explore the essential aspects of proper circuit identification. Each circuit must have clear and durable labels at every point where it is accessible, including within the junction box, at the circuit breaker panel, and at any other termination points. These labels should include the circuit number, such as circuit 16 or circuit 14, and the voltage of the circuit, typically 120 volts for standard residential circuits. Consistent labeling throughout the electrical system minimizes confusion and reduces the risk of errors during maintenance or repairs. The labels themselves should be made of a material that is resistant to fading, moisture, and physical damage to ensure long-term legibility. In addition to physical labels, consider creating a detailed circuit directory at the main electrical panel. This directory should provide a comprehensive listing of all circuits in the house, their corresponding numbers, and the specific loads or areas they serve. This directory can be invaluable for troubleshooting and identifying the correct circuit for any given task. When adding new circuits or modifying existing ones, always update the circuit directory to reflect the changes. Next, let's cover the importance of a common overcurrent protective device. Both circuits sharing a junction box must be protected by a single circuit breaker or fuse that is properly sized for the combined load of the circuits. This overcurrent device is designed to interrupt the flow of electricity in the event of an overload or short circuit, preventing damage to the wiring and reducing the risk of fire. When selecting the appropriate size for the overcurrent device, it's crucial to consider the ampacity of the conductors and the maximum load that the circuits are expected to carry. The overcurrent device should be sized no higher than the ampacity of the smallest conductor in the circuit. For example, if one circuit uses 14 American wire gauge (AUG) conductors with an ampacity of 15 amps and the other uses 12 AWG conductors with an ampacity of 20 amps, the overcurrent device should be sized to 15 amps. It is also essential to ensure that the overcurrent device is properly rated for the voltage of the circuits it is protecting. In residential applications, this is typically 120 volts or 240 volts. Using an overcurrent device with an incorrect voltage rating can compromise its ability to protect the circuit effectively. Regular inspection and testing of overcurrent devices are essential to ensure they are functioning properly. Circuit breakers should be tested periodically to verify that they trip correctly under overload conditions. Fuses should be inspected for any signs of damage or deterioration and replaced as needed. Now let's move on to conductor sizing for proper amperage. The conductors used for each circuit must be sized appropriately to handle the maximum current they are expected to carry without overheating. The NEC provides detailed tables that specify the ampacity of different conductor sizes based on factors such as the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. When selecting conductor sizes, it's crucial to consider the anticipated load on each circuit. This includes all appliances, lighting fixtures, and other electrical devices that will be connected to the circuit. The conductor must be sized to handle the total load with a safety margin to account for potential future expansion. In addition to the load calculation, it's also important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a long circuit is lower than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause appliances to malfunction and can also lead to overheating of the conductors. The NEC provides guidelines for calculating voltage drop and recommends using larger conductors to minimize voltage drop in long circuits. When running conductors through conduit or cable, it's important to follow the NEC guidelines for fill capacity. Overfilling a conduit or cable can lead to overheating of the conductors and can also make it difficult to pull the conductors through the raceway. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit or cable based on the conductor size and type. Lastly, we will review box fill requirements. The junction box must be sized appropriately to accommodate all the conductors, splices, and devices that will be installed within it. Overcrowding a junction box can make it difficult to make proper connections and can also lead to overheating of the conductors. The NEC provides detailed calculations for determining the minimum size of a junction box based on the number and size of the conductors and devices it will contain. These calculations take into account the volume occupied by the conductors, the devices, and any internal clamps or supports. When calculating box fill, it's important to include all conductors that pass through the box, even if they are not spliced or terminated within the box. Each conductor counts towards the total box fill calculation. In addition to the conductors, any devices installed in the box, such as switches, receptacles, or lighting fixtures, must also be included in the box fill calculation. The NEC specifies the volume occupied by each type of device. When making splices within a junction box, it's important to use approved connectors that are properly sized for the conductors being joined. Wire nuts, terminal strips, and other approved connectors provide a secure and reliable connection that will not loosen over time. All splices should be made within the junction box to protect them from damage and to prevent accidental contact with live wires. When installing conductors in a junction box, it's important to leave sufficient slack to allow for easy connections and future modifications. The NEC recommends leaving at least 6 inches of free conductor length at each termination point. This allows for some flexibility in making connections and provides room for future adjustments or repairs. It's also important to ensure that all conductors are properly supported within the junction box. Conductors should be secured to the box using clamps or other approved methods to prevent them from pulling on the connections. Proper support helps to maintain the integrity of the connections and prevents damage to the conductors. In addition to following the NEC guidelines for box fill, it's also important to consider the practical aspects of working in a junction box. Choose a box that is large enough to allow you to make connections easily and to provide enough space for future modifications. Avoid overcrowding the box, as this can make it difficult to work and can increase the risk of damaging the conductors. Consider the location of the junction box when determining its size. If the box is located in a confined space, it may be necessary to use a larger box to provide adequate working room. The NEC provides additional requirements for junction boxes located in damp or wet locations. These boxes must be specifically listed for use in wet locations and must be designed to prevent water from entering the box. In addition to following the NEC guidelines, it's also important to use good workmanship practices when installing electrical wiring. Make sure all connections are tight and secure, and that all conductors are properly insulated. Avoid nicking or damaging the conductors, as this can create a potential hazard. It's also important to test all circuits after they are installed to ensure that they are working properly. Use a multimeter or other testing device to verify that the voltage and current levels are within acceptable limits. These safety considerations and requirements are aimed at preventing electrical hazards and ensuring the safe operation of electrical systems. By adhering to these guidelines, electricians and homeowners can minimize the risk of electrical fires, shocks, and other accidents. The NEC is a comprehensive set of standards that provides detailed guidance on all aspects of electrical installations. It is updated regularly to reflect the latest advances in technology and safety practices. Electricians and other electrical professionals are required to be familiar with the NEC and to follow its guidelines when installing or modifying electrical systems. Homeowners who are performing electrical work should also be familiar with the NEC and should follow its guidelines to ensure their safety. In addition to the NEC, many local jurisdictions have their own electrical codes that may be more stringent than the NEC. It's important to check with the local authorities to determine the specific requirements for electrical installations in your area. Electrical work can be dangerous if it is not performed properly. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work. A qualified electrician has the training and experience to perform electrical work safely and in accordance with the applicable codes. If you are planning to combine two different circuits in the same junction box, it's important to carefully consider all of the safety considerations and requirements discussed above. Make sure you have a thorough understanding of the NEC and any local electrical codes that may apply. If you are unsure about any aspect of the installation, it's best to consult with a qualified electrician. By following these guidelines, you can help ensure that your electrical system is safe and code compliant. Remember that electricity is a powerful force that can be dangerous if it is not handled properly. Always take precautions to protect yourself and others when working with electricity. Wear appropriate safety gear, such as insulated gloves and safety glasses. Turn off the power to the circuit you are working on before you begin any work. And never work on electrical equipment when you are wet or standing in water. By following these simple safety rules, you can help prevent electrical accidents and ensure that your electrical system is safe for everyone. Combining circuits in a junction box is just one aspect of electrical work. There are many other topics to learn about, such as wiring methods, grounding, bonding, overcurrent protection, and electrical safety. The more you learn about electricity, the better equipped you will be to handle electrical tasks safely and effectively.